Yeah, I can hear you, Les. Thank you.
And can you see my the video and the shared screen?
Yes, I think so. The video's in the bottom right-hand corner, I think.
Perfect. Good. Come on in. Right, good morning. My name is Les Frost. I'm a technical architect, and I'm talking to you about artificial intelligence. So hopefully that's a term that quite a few of you have heard. So I was going to give you a sort of high-level overview of it. Welcome to this place called the Tech Hub. Just do a bit of marketing, I suppose. So the Tech Hub, this area here, we use quite often for technology-related events. You're probably aware that our customers are becoming more and more technology savvy, and more their expectations are that they expect people to be innovative. So this is a space that we use for doing technology sessions for everybody, regardless of whether you're deep into technology or just want a little taster. Open to everybody. Lots of sessions go on in here, so if you're interested, most of them are on the Event Hub nowadays. Right, so I'm going to talk about what is AI. I'm going to touch on some of the terminology that you might hear if you were having a customer discussion with AI. About AI, you might hear people talk about machine learning or deep learning or some of these terms that are bandied around. So I'm going to go through those. I'm going to talk about why it's happening now. Why is there interest in this area all of a sudden? Some different aspects of AI. Natural language understanding, that sort of thing. Common use cases that people use AI for. What sort of business problems do they solve with them? A little bit on the HMRC AI strategy, which some of you might have seen a presentation by Shailesh, which talks about that in detail, but I'll just touch on it a little bit. Some contacts and some resources if you're interested in finding out more. Right. Who thinks it requires intelligence to solve the Rubik's Cube? No?
Yes.
Yes?
Yes.
Yes, okay. So here we have a Lego robot. It is, let me just share the... It is capable of solving the Rubik's Cube. Let me just make this bigger, then people can see. How do I make that bit bigger? Can I do that? I'm not sure I can now, actually. Anyway, you'll have to see it at this size, I suppose. So this is a Raspberry Pi Lego robot that, the way it works is it takes a photograph. So you have a Raspberry Pi and a Raspberry Pi camera. The Raspberry Pi is a cheap computer. It takes a photograph of the Rubik's Cube, each of the 6 faces. Yeah? And then it uses computer vision to look inside the photograph and say, well, it's told, find a cube. So it basically does something called edge detection. It detects the edges of the cube, and then it looks inside that cube for the other edges. So it basically detects each face. It's a colour camera, so it knows what colour they are. And then effectively it can solve it. Yeah? So there's a good example of something that's using image recognition and image processing to solve a cube. Some people think that's intelligent. Yeah? Some people don't. I don't, particularly. But that sort of concept is interesting because when it comes to the definition of AI, there isn't really a good one. Right? But if you're having a conversation with customers, I think the way to think about it is probably this thing. Most people are focusing on trying to make computers good at things that humans are good at. fundamentally. So what sort of thing are we good at then as humans?
Solving problems.
Yeah. What am I doing now? Talking, yeah. You're listening. Hopefully you're understanding. You can see me. You can recognise me if you knew me before. So there's a whole host of sort of properties, I suppose, that humans have. What most of the fields of AI do is try to computerise that. And then it appears intelligent because you're giving a computer a property that you associate with a human. And that's what most people, I suppose, in business terms, sort of think about when they talk about AI.
Let's ask a question, because I would have said one thing humans are good at is creativity. And obviously that's a bit of a...
So I'll come on to that. I'll actually come on to that in a moment, because in fact this very term here. So Shailesh's presentation on the HMRC AI strategy has this in it, which I think is quite nice. This talks about different aspects of AI, and I'll go into these, but it talks about types of AI. Specialised is the one I've just talked about. That is specialised. It does one thing. It is doing computer vision to work something out. I, as a human, I've got generalised AI. I can talk, reason, you can be innovative, you can have a hot creativity, all those sorts of properties. So that's quite interesting. And I'm going to go into these terms. You'll hear people talking about... Sorry?
You can make mistakes as well.
Absolutely. Yeah, absolutely. So learning, learning from mistakes. You'll hear people talk about supervised and unsupervised AI, and I'll go into that in a moment. Probably not going to touch on that because that's quite advanced. Modelling, you'll hear people talk about machine learning and deep learning. These are different types of AI algorithms. At the end of the day, most AI is mathematics and probability. It's not magic. It's maths. So if you go into a few of those things, specialised AI, that's effectively when we take one skill. It might be listening, it might be image recognition, but a specific skill. Generalised AI, that coming to your point, that's where people think AI is going. That's when you read the books about science fiction books, that's what people are talking about. Generalised AI, the ability to reason, the ability to do multiple of these specialised things, the ability to be self-aware, all the things that humans do, years away, right? Many, many years away, and potentially not even possible, right? So when people talk about AI, they're generally talking about specialised AI, doing a particular thing that humans do. The next term you might hear, people talk about supervised learning. This is the idea that you teach an algorithm to do something by giving it examples. So let me make this real a little bit. So this is one of the things you do when you do early image detection. You build a classifier. So what this one does is you give it 10,000 photographs of cows, and you say to it, those 10,000 things are cows. You give it 20,000 photographs of other things, and you say, these things aren't cows. So all you're doing is classifying stuff. You're saying, that's a cow, that's a cow, that's a cow, that's something else, not a cow. And effectively, you can take an algorithm, you can feed it this information, and effectively it's like a fancy pattern matcher. Yeah? It works out that cows have particular properties in an image. And that's basically what it does. They have legs, they have ears, they're generally black and white. And it sort of builds a matcher that says, that looks like a cow. It's all based on mathematics and probability, but that gives the impression that that this piece of AI can do something. Now, this is a tool. This is its interface for building this AI, but fundamentally, it gets to the point where you drag photos onto here and it says, yes, that's a cow. Yeah? That's not a cow. Yeah? So in technology terms, I mean, you can, if you were a Python programmer like me, computer programmer, it's not very many lines of code to do that whole thing, because it's using a whole set of libraries that have been built up over years. But fundamentally, the idea is this is supervised learning. You say to the algorithm, here is some data, and it's of a particular type. It's a cow, or it's not a cow. You give it thousands of examples, and it builds an understanding, quote, of what a cow looks like. Now, you'll realise when you get into this field that the data part of that's really important. So if you take something like a zebra, right, and you tell this thing, here's 10,000 pictures of cows, here's 20,000 pictures of things that aren't cows, but you don't put a zebra in the data, and then you give it a zebra, it goes, oh, actually, this looks like a cow, because it's sort of black and white and looks so again, the way this works is, yeah, the algorithm stays the same, and you basically feed it with data. But then you've got to be very careful about what's in the data and whether the data gives you coverage. And you'll hear people talk about bias in data. So, for example, a lot of initial facial recognition software, images of people, was biased. It was much better at recognizing white skin than it was black skin faces, because the data that it was used to teach it was heavily biased. Yeah? So again, you have to be careful in this area, because the conclusion it comes to is heavily based on the data that you feed it. So that's quite an interesting area of AI. So you'll hear people talk about the ethics of AI, you'll hear people talk about whether you've got bias in your data. Yeah?
Is it not just fuzzy logic?
Yes, it is fuzzy logic, yeah, absolutely. And you're used to doing that in pattern matching in text, and these algorithms are able to do that in pattern matching of generalized data, including images. But that's a good way to think about it. These types of things are, yes, fuzzy logic around images. There's quite a lot to it in the background, quite a lot of mathematics, but that's a good way of thinking about it. Another example might be, let's say you've got, I don't know, house prices. Yeah, you've got the size of the house, where it's based, the age of the house, and the price. And you build a model, you teach a model that, a 3-bedroom house in Telford is roughly worth this much money. You've actually got the price, so you're teaching it based on knowing the answer. That's supervised learning. There's another complete class of AI which is much more difficult, which is unsupervised. So in that case, it's a bit like when we learn. Yeah, when we're young, our mothers and fathers might say, that thing over there's a cow. That's supervised learning. We might just get up and bump into a chair leg and work out that it's hard. That's unsupervised learning. No one's told us, we just learn it over time. And that's essentially what unsupervised learning is. This is generally, you give it a class of data, and it's trying to sort of classify data into various matching areas that match, but you don't tell it what the answer is. So models like this tend to be really bad when they start off, but as you give them more and more data, they become more and more accurate. Models like this that are supervised tend to be quite good from the start. That makes sense? The other terms you might hear people talk about are machine learning. Anyone heard that term? Yeah. So that's a subset of AI. AI is like a generic term. It's a subset of AI, all to do with algorithms that learn. And you might hear this term deep learning. And deep learning is a subset of machine learning, but they use special sorts of algorithms, and they're called neural networks. Now, it's hard to explain, but The idea in a neural network is it's supposed to be modelled on the brain. I think that's a little bit of a stretch, but the basic idea, and those on the phone can't see me drawing on the board, apologies, but the basic idea is that you build a network of nodes, and each node does a particular thing. So let's say I wanted to recognise the numbers 0, 1 and 2. And if I take the number 0 as an example, and I look at, let's say I take a photograph of the number 0. So someone's written the number 0 and I've taken a photograph of it, and these are all the pixels in the photograph. Then I might recognise that here, in this area of the photograph, that there's a line, and I might, if I took each of these pixels into this neural network, I might recognise that, yeah, there's always a line in a 0, there's always a line at this point, and there's a line slightly up to the right of it. And I quite often get these collection of pixels in a 0, whereas when I look at a 2, I don't. And so what happens in these neural networks is that each of these nodes might look at a portion of the photograph and say, yeah, I'm, if there's pixels there, I'm 80% sure that this is a 0. And then it sort of feeds onto the next tier. And this might say, oh, well, if there's pixels there and there's pixels to the right of it, then I'm pretty sure now that we're sort of getting towards a 0. Quite difficult to explain, but that's the basic way these algorithms work. They have layers of, conceptually, layers of nodes that look at a particular, so say a cow, there'll be things that are saying, oh, I recognise there's a foot, oh, I've got 4 legs, I've got a face, I've got an ear, and all this stuff sort of shuffles towards it being a cow or not. So that's sort of how they work behind the scenes. Quite difficult to explain, but you might hear people talk about a neural network. It's the way brains work. Our brains made up of neurons with synapses between them, and things get associated. And that's, so deep learning is this idea that you build algorithms based on that idea. There's a lot to that. So why do we think AI is relevant now? Why is everybody talking about it? Any ideas? So I did a degree in computer science in 1983. I graduated, so that makes me really old. And at the time, most of the algorithms that we use today in AI existed. So I learned them 30 years ago, 35 years ago probably. So it's not that we haven't had the algorithms. The algorithms, most of them were written in the 1950s and 60s. So neural networks were invented many years ago. What we didn't have, however, was a lot of commodity computing power. Yeah. So this sort of calculation, which is all numbers, is really good for graphical processing units. So if you're a games player and you buy one of those complicated GPUs to accelerate your graphics, they're really good at doing number crunching. So one of the reasons why AI is important now is you've got computing power that can process the algorithms that you've had for 30 years. But probably the most fundamental thing is data. So last year alone, something like 1.4 trillion photos were uploaded to social media, right? I've shown you there that you can look inside an image and see a Rubik's Cube. Well, if you ever want to know why a lot of people are interested in image recognition particularly, it's because they're a marketer's dream. So I'm a cyclist, right? So if I upload a picture of me on a bike, they can look inside the picture and work out Les Ross likes bikes, and actually he's got a bike which is a felt bike because I can read it on the side of his bike, right? So certainly from a marketing perspective, AI is quite big business because of the knowledge that you can get out of things like photographs. But it's the combination now of the algorithms, the computing power, and the data that makes it so powerful. That's why it's taking off, and that's why people are talking about it. So if we look at different aspects, you've got things like natural language processing. What do you think that means?
Free text.
Say again?
Free text.
Free text is one, yeah? Yeah? But what does it mean about free text? What are we trying to do?
Like sentiment analysis and all that kind of thing.
Yeah, absolutely.
What we're trying to say, if there's anything.
Absolutely, yeah, yeah.
Keywords, it's probably like the keywords.
Yeah, yeah, good. So there's that whole natural language processing. Then there's quite a chunk around image recognition. Can you recognize objects? Can you recognize faces? All that sort of stuff. So, Alexa, how many miles to the moon?
The moon is 238,858 miles away.
Yeah, so what just happened there? I asked a question, yeah, and she answered. So how does that work?
Doesn't it recognise those particular words?
Speech recognition.
Yeah, speech recognition, yeah. But fundamentally, you know, that little box there is just a microphone. What it's done is it's taken a digital snapshot of the words I said. It's sent them off to, in this case, the Amazon cloud. It's looked at those wave patterns. Yeah, so voices are wave patterns. It's looked at the wave patterns. It's worked out the words it's got a big neural network which understands wave patterns and what those words mean. It's then looked at the sentence and worked out the meaning of the sentence, and then it's Googled an answer and effectively spoken back the answer. That's one aspect of natural language processing and becoming very relevant. There's a really good Capgemini report on sort of interactive conversational AI and how that's going to take off. That's quite good. But in short, that whole sort of voice-driven stuff is driven, you know, there's lots of research on that. It's turning into products. You might think they're gimmicks. Personally, I don't. I think voice interaction will become quite prevalent. I don't know how many of you have seen how many people have watched this? This is Google.
I want to ask Google to make you a haircut appointment. So what you're going to hear is the Google Assistant actually calling a real salon to schedule an appointment for you.
Don't have to hang off here. Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second.
That's quite simple, isn't it?
That was the real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years.
So that's an example where they basically just get Google Home to bring up restaurants and bring up salons and book meals and book, you know, and it's very difficult if you watch those sorts of videos. I know they're slightly staged, but fundamentally that's the sort of thing that these assistants will start to do. So you saw that, that's quite a subtle, yeah, so they're not simple now, they're getting quite sophisticated. So natural language processing, definitely a big area. Now, if you come to text analysis, you'll realise that loads of industries have loads of unstructured data in documents and spreadsheets and a whole host of things. And actually, if you look at use cases, they're generally completely across most sectors. Yeah. lots of people are looking at this sort of area. So this talks about loan contracts or insurance policies. So it's text, but it's quite specific text. It's an insurance policy, and what you're trying to work out is whether you're covered. Yeah. So it's not general text; it's quite specific text. And again, those sorts of things. Is somebody covered for this thing in this insurance policy? Is the sort of thing that natural language processing is really good at. So lots of examples, credit card fraud, a whole host of areas. So that's why people are interested. We've got the power, we've got the data, it's quite relevant across many industries and therefore big business. So object recognition. If you're ever worried about Facebook, go and read the Cats and Dogs. This tries to work out whether you're a cat lover or a dog lover by just looking at your photos. Oh, and what you've posted. Yeah, and the reason is they want to sell you dog food or cat food. Fascinating, absolutely fascinating if you want to read it. But this comes to the point of, if you don't pay for Facebook, why do they have it? The answer is you are what they want, right? So you are providing data that they want to use to market. And more, that data is in photographs. Yeah, photographs are very rich in terms of, and so in this case, they were just basically trying to look at what you posted and said, yeah, Les likes dogs, so-and-so likes cats, let's sell them dog food or cat food. Yeah, so that's big business. Marketer's dream, really. Facial recognition, you've all seen this, iPhones, a whole host of things. Facial recognition, yes, it's got some flaws, but you can get to the point of it being useful for quite a few things. I mean, I have an account on Atom Bank. I log in with my face. iPhones log in with your face. They are pretty good nowadays. I mean, someone mentioned sort of gesture analysis and sentiment analysis. This is another aspect of facial expressions, looking at people's faces and trying to work out whether they're happy. A recent tech challenge, I think in the last one, did this with the Microsoft software. We showed it to McDonald's in here, and they went, wow, so we could look at our customers and work out whether they're happy or not then. And you think, that's beginning to be a bit Big Brother, isn't it? But, that's possible. And again, it's possible because there is a data set which has pictures of facial expressions. You can teach, just as we did with cats and dogs, you can feed these examples into a neural network and get something which is quite good at telling whether people are happy or sad, as in the Microsoft software. They've preloaded a neural network, loaded it into Azure, their cloud, and then you can use it for effectively facial expression analysis. So that's quite interesting. Skin cancer photographs, they're just photographs at the end of the day. A neural network taught, just like we did with cats and cows and non-cows, a neural network, a deep learning network taught on dermatological pictures of skin cancer is now better than most dermatologists. All right, so again, whether you'll be seeing this in your local hospital is a good question, but there are already hospitals that use this sort of idea. So this is simply saying, from an image of a piece of skin, I can tell, with a high likelihood whether it's cancerous or not. Yeah. At the end of the day, that's what humans do. They look at it and they work out based on their experience whether they think it's cancerous or not, whether it needs a biopsy or whatever. They're just images. Computers are far better at analysing images, actually, than we are in some circumstances. But again, you've got to be clear about the data. So in this case, it's all medical data, and therefore, there's a wide range of it. It's probably not biased because it's been taken from the general population. So that's quite an interesting aspect. Anyone ever built an extension? No?
Personally.
This is something that Capgemini did for Travis Perkins. Yeah, it's a mobile phone app. It starts off on your phone. It tells you what to do. It gets you to take a picture of your brick. That's a brick from my house. And then it says the best brick. If you're going to build an extension and you want to match with that brick, they're the bricks you want. Yeah. So that again is what they've done. Is they've taken the 20 bricks that Travis Perkins have. They've got loads of images of them in rain, in sunshine, with a bit of moss on them. They taught a neural network. They've said those 50 or those 500 bricks are of a particular type, those thousands are of a different type, and then effectively it takes your image and it classifies it. What sort of brick does it best match with? And that's exactly the same as the cow and no cow idea. It's just a set of images. You've told it that images that look like that are that sort of thing, and images that look like that are a different sort of thing, and then you give it an example and it says, well, matches. Does it match it? Yeah, that brick is closest to that one. And that's effectively how it works. So that's something Capgemini's done. That can be taken to different areas. So this is what's wrong with my tea plant. Yeah, I go up, I scan a leaf, and it says, oh, well, leaves that look like that have got that disease. And so you get the idea. Effectively, any sort of data that you have in images that can be classified, you can build a classifier that allows you to take a photo and put it into one of those categories with a high, 85% chance. We're not talking absolute. This is all probabilities. Yeah. See someone wearing something you like, take a photograph of them and find similar clothes. Quite interesting. So the ASOS team that wrote this are in Birmingham, and we run a meetup. In fact, we've got one tonight, and some of their guys will be here. So this is quite big business for them. They're innovative because they've come up with this idea of snapping photos of people and saying, I want to wear what he's wearing or she's wearing. I haven't tried it out. I don't know. I don't think anyone dresses like this. So I think, but again, have you? Yeah, absolutely.
He sent me a picture of Woody saying that looks nice, and I brought a video of ASOS.
Yeah, well, there you go.
I guess if you saw someone wearing something on Instagram or something, then you could
use that picture rather than
absolutely. but that's quite interesting, isn't it? I mean, that's an online fashion store using that sort of So I do quite a few AI competitions in my spare time, and this was quite a recent. This is the sort of thing that they were doing a year ago. Effectively, you were given an image, and you had to work out whether the driver was distracted or not, essentially. So generally what you do is you look to see where their eyes are and whether they're looking forward. You look for objects in the photo, like phones. You do all that sort of thing, yeah? And, that works reasonably well. And if you ever enter an AI competition on a site like Kaggle, which is like a universal competition, people can get accuracies of like 98%. So they can 98% of the time solve that problem, work out whether somebody is distracted or not. And you think, well, lorry drivers, we quite like that. In lorry drivers' cabs, wouldn't we, to stop them ploughing into people? That would be quite good. You might have seen, has anyone seen this DVLA thing that the AIE did?
Welcome to DVSA's driving portal. This portal is designed to help learner drivers have their theory test well. We are now going to follow Dan, a learner driver looking to take his theory test. First of all, Dan registers his details on the DVSA website, including his driving license number. Dan is also required to take a photo. This will be used to reference against the source driving license image stored in the DVLA database. Once Dan has registered, he will receive a confirmation email to log in. Dan accesses the online portal. The portal is made up of 3 distinct areas. The Learn Zone gives you instant access to all of the official revision questions. The Practice Zone allows you to see if your knowledge is up to scratch in a test-ready environment. And when you are ready, the Test Zone allows you to take your test at home. All of the tools you need in one place. Should Dan have any queries, you can speak to our live chat bot. When Dan is ready to begin the test, he is giving a briefing around how the test will work. To ensure Dan is completing the test in a controlled environment and is fully aware of test protocol, he is taken through a series of instructions. These include making the candidate aware of the ways in which we are monitoring them, drawing their attention to our facial recognition monitoring that will monitor them closely through the test, emphasising the need to stay within the frame, highlighting items that are prohibited throughout the test, making the candidates aware of their room requirements, ensuring they have enabled their microphone and other remaining hardware components, making them aware the test will be conducted in full screen and any access to restricted aids will be flagged. And finally, we ensure that they are aware of their facial positioning throughout the test. Before the test begins, Dan is required to confirm that he agrees to the terms and conditions of the test. He is asked to type a declaration. This reinforces that the test is to be taken seriously and also provides the opportunity to capture Dan's unique keystroke. To cater for users who feel less confident typing, we have included an alternative way to capture the individual's unique marker. Users have the option to record their voice as a baseline, which can be used to authenticate themselves after the test. Dan is now ready to begin the test. Upon starting the test, Dan is taken to a full screen, which when minimised will automatically void the test. As Dan answers the questions, he is being monitored by a range of technologies. These include a live image of Dan displayed at the bottom left of the screen, reminding him that he is being monitored and to ensure he keeps his face within the frame. After completing the test, Dan is asked to fill in the end of test declaration via a keyboard or voice. This completes Dan's authentication. Dan has now completed the driving theory test. He will receive his results via email. Dan is now redirected back to the DVSA driving portal, where he can continue his lifelong driving journey. If any instances of potentially fraudulent activity is recorded during Dan's test, it will automatically be flagged for review. Now, let's see what happens post-test, joining our colleague in a fraud investigation team. Mike is a senior fraud investigator. He logs into his staff portal and sees that he has new flagged tests that require investigation. He can see Dan's test has been flagged, and whilst he passed the test, there are a number of fraudulent instances that need reviewing. Mike enters the test investigation screen. This insightful tool empowers Mike to make a decision on whether the flagged test was carried out fraudulently or not. Here, Mike can see Dan's details, his reference photo from the DVLA database, the fraudulent instances, and also the test recording. Using the playback feature, Mike can watch the entire test or quickly skip ahead through the specific fraudulent instances. Mike can easily filter between the different types of fraud indicators and view the insights the technology is flagged. Let's have a look into Dan's instances of fraud. It appears Dan has had one instance of where facial recognition has flagged fraudulent activity. Here we can see that Dan has had support from another individual in the room. On reviewing the object detection instance, it appears Dan has used an electronic device to support him during the test. Whilst the keystroke analysis has not flagged anything, Mike still has the ability to go in and review the confidence level. Our background noise indicator has flagged an additional voice in the room supporting Dan. Let's see what happened here. Whilst Dan's colluder wasn't detected in the frame, this audio clip confirms that somebody else was helping.
Which one do you think?
It's number 3.
Okay.
So I guess you get the idea, yeah? Yeah. So that was a prototype put together by the AIE in London for DVLA. And as you can see, uses a whole host of, you might consider intrusive technologies, but in that particular case, they were looking at whether they could do your theory test at home as opposed to sending you to a special place. Again, whether that will be rolled out, it's probably a little bit from production, isn't it? Because it relies on people having cameras and microphones and a whole host of stuff, but it just shows you the sort of thing you can do with it. I think that's quite a realistic example. This is my favourite. I've spent many an hour trying to solve this generic problem. So there are a whole host of competitions now on AI sites associated with car park space finding. Yeah. So the idea is you have a camera from the top of the building and you work out where the spaces are, and effectively you scan through these images looking for cars and then looking for spaces between cars that are roughly the size of a car. It's like that, but much more complicated. But fundamentally, that's the sort of competition that's currently going on AI sites. That whole, from a generalized picture of a car park, find spaces. And then actually, not only find spaces, but look at the demographics of the cars. How, so if you're a shopping centre and your car park is full of really expensive cars, that's really good. So again, that sort of thing happens quite a lot now.
So when you say you've been spending time in these competitions, what are you doing submitting? Are you writing algorithms to do your writing?
Yes, or using... The algorithms exist. What you're trying to do is you're trying to design a neural network. Neural networks have lots of layers, and each layer does different things, and combining them in different orders gets better answers. So most of the competitions, the algorithms already exist. What you're trying to do is use those algorithms to get a high degree. Anybody can enter. The people at the lowest end of the competition are probably just getting better than guessing, like 50% certainty. The people who win are like 95% certain that's a car park space. I'm not very good at it, so I come in the sort of middle.
What do they get?
If you win, hundreds of thousands of pounds.
Oh, do you?
Yeah,
Okay.
absolutely. Yeah, it's big. There are people who do it professionally. Hundreds of thousands of dollars for winning.
So we're looking at this as part of the same.
Yeah, I was going to say, so if you ever get into this technology, it's really good. Obviously, they're trying to find, most of those sites are trying to find programmers that people like Google can then get onto their automatic steering and all that. So, that's an example. Automated driverless vehicles, effectively. If you think about it, you're taking an image of what's coming towards your car and you're effectively trying to dodge obstacles. Most of that is driven by deep neural networks looking at objects effectively in your sight. Lots of other detectors as well, but quite a lot of it is object recognition. Right. So hopefully that's given you a general idea. Looking at text that people speak, looking at text that they write, looking at images, that whole area is mostly where AI gets focused. HMRC opportunities. Let's get on to some real stuff. So this is from Shailesh's presentation. If you haven't seen it, I suggest you get him to come and give you a presentation. So fraud detection, text analysis we talked about earlier. This might be people tweeting about HMRC, trying to get some sort of sentiment from what they're saying. Are they happy? Chatbots, all that sort of stuff. A whole host of stuff around helping people decide on tax questions, the whole sort of RPA, robotics stuff. Can we use some more AI in that? So this is quite a good presentation from Shailesh. I suggest you talk to him about going through it. A lot of it is based on unstructured data. It's probably applicable to the vast majorities of HMRC because they all have loads of unstructured data. A lot of it is based around natural language processing, understanding text, semantic analysis, understand what people are meaning by that text. So lots of examples of textual processing. The other thing HMRC are looking at is this idea of AI ops. So this is AI applied to live operations. So generally, if like me, you've been involved in lots of live incidents, logs of what's happening to the infrastructure and what's happening to applications are a goldmine. You look in logs to find out what's gone wrong with applications. Well, wouldn't it be nice if you had some tools to look in the logs automatically for you? Wouldn't it be nice if you knew what normal looked like? Let's say you had a time series of, let's say, the CPU on a server. Let's say you had a time series and you knew that at lunchtime it generally goes high, after lunch it goes low, and then today you compare what you see today with what you normally see and say, oh God, that's a bit different, isn't it? Something going on there. So AI applied to operations, quite a big field. Fundamentally, it's looking for patterns in log files and trying to associate those with things that aren't normal. Things are failing, and therefore you need to go and look. Quite a lot in this area. A lot of vendors, so a lot of network monitoring tools, application monitoring tools have got this, are starting to build AI into their tools to allow you to do that sort of thing. So this is a good example, I think, which Shailesh goes through. This is the idea that HMRC have caught somebody who's smuggling tobacco. Yeah, they're using a burner phone, you know, a phone they just bought with no identity on it. You've got some information from the port, you've got some pictures, you've got a list of people that you might be interested in, you've got some data about where the pictures are taken, you've got some number plate recognition data, you've got some emails, you've got some data from their laptop that you've confiscated. You've got all that data, how do you analyse it? You know, today, that would take an army of people to look through. Read all the emails, work out who the interesting people are within the emails, work out who's been talking to who from the phone records. It's a massive job. So this is a really, you know, if you want to search it, you want to work out where the people are that are involved in all this data, you want to map it to a physical map, you want to connect people together. You'll have heard of our Connect system. Yeah, this is the sort of idea. So, you know, it used to be the case that a lot of fraud was based on, you know, data inside databases that you could easily get at, but today that's not the case. It's contained in loads of different sources, and you have to join it all together in order to progress. And the AI applied to that problem of, you know, generalized searching, matching stuff together, matching images of people with persons of interest and where the photos were taken, you know, where the car was from its number plate, all that sort of thing. It's all about gluing data together. And again, that's an excellent area for these sorts of techniques. So there's a couple of ways you can do AI. You could do it sort of bottom up. So you could write Python programs that do much like we did with that cow thing. You can start from the bottom up and do it all yourself, or you can buy tools that do it. And currently the HMRC AI strategy, working with ourselves, is a tooling approach. So for example, HMRC are heavily into SAS. SAS comes, they've been analysing data for years. It comes with some really serious AI algorithms built into the SAS tool. So what Shailesh is trying to do is to use a top-down tooling approach to AI. And he's coined that enterprise AI, meaning, you know, it's a sort of focus on business value as fast as you can by using tools that have a whole host of stuff built into them. They're expensive, but they'll give you answers quite quickly, as opposed to start from the ground up and build it all in Python, which is, you know, it's expensive from a manpower perspective, and, you know, you're going to learn a lot, but it's going to take you a long time. So time to value becomes much longer. So that's where Shailesh and his team are focusing. Get tools, have a platform which allows you to run those tools, so the SAS Analytic Cloud or potentially AWS running SAS. Build strong relationships with partners, train people in those tools and the use of them, and then get close to the business and try and use those tools to solve their problems. That's effectively, at a very high level, what the current strategy is. So if you haven't seen Shailesh's full presentation, I think it's worth looking at it. If this has sort of interested you, there are some really good resources that you can get access to. This one's really good, the Executive Guides to Artificial Intelligence, a physical book or an e-book, really good. Quite a high-level summary of businesses that have used AI. That's really good. This one's really good, AI Superpowers. This is about the next sort of industrial revolution, if you like. How a lot of people think that AI is the next differentiator between between countries, like the next Cold War sort of thing, and specifically the comparison of Chinese AI technology versus American AI technology. Quite interesting. Who's got access to this thing called Pluralsight? Anyone come across Pluralsight?
Yeah, I've got access, but we can
Right.
get access if you need to.
Yeah, so Pluralsight is a online learning facility that we all have access to. Lou Dean, if you email Lou Dean and say you would like access to Pluralsight, you should get it. There are some really good presentations in it. This one's really good. Understanding Machine Learning by Dave Chappell. It talks through, some of them are really technical, but this one's an overview of machine learning. It talks you through how you go about it. It's probably 50 minutes, is it, something like that? And it's really good. It's sort of next level down from what I've been talking about. But there are, there's stuff there if you're interested. And if, like me, you're a podcast listener, so I have quite a big commute, so I listen to podcasts quite often, so audio stuff. If you've got a podcast application, Apple Music or Google Play or whatever, this one's quite good. Artificial Intelligence in Industry. This again talks about business applications of AI. They're like 20-minute podcasts every week, just looking at different aspects. So I think again they're quite good if you're more interested. And I think that's where I'm going to stop. So hopefully that was a bit of a whistle-stop tour through the various different areas. But hopefully that's got you thinking about, what is AI? What does it mean? If somebody asked you what it was, you'd be able to say, it's the idea that we're making computers do things that humans are good at. If someone said to you machine learning, hopefully you'd know that that's an algorithm that you pile data into and you can use it for different types of things, a lot of image recognition. So hopefully that's given you a sort of taster.
Okay, thank you.
Any questions, or was that all?
Something the name isn't it? It's quite scary for some people because there is resistance to its use and obviously security concerns.
Absolutely.
The natural resistance. But I think the way you presented it, presents it in a slightly more open, slightly more friendly way, and it makes it more attractive if you were resistant. I just think it's something maybe the use of AI, intelligence is quite a
emotive
statement, isn't it? Whereas
yeah.
what you're talking about is actually, it's almost automation, it's a kind of progressing thing.
It is, yeah.
It's some learning, but it's a bit more subtle.
Yeah.
And I know that the term is stuck now. It is AI.
Yeah, absolutely.
So,
yeah.
A lot of people are quite fearful and people don't really understand what it is.
Yeah, absolutely.
Les, I've got a question for you on the phone. It's perhaps a slightly unfair question, and okay if you don't want to address this one, but what do you think the impact of quantum computing will be on AI, particularly things like deep learning?
So quantum computing is, so computers today are binary. They work on the idea of ones and zeros, and they're sort of running out of power. So computers have become faster and faster by miniaturizing transistors, making them smaller and smaller. But they're now getting to the point where physically they can only cram a certain amount of transistors on a piece of silicon. Quantum computing is a completely different way of computing. These are super cooled pieces of machinery that don't work in ones and zeros, they work in quantum states. It's like really deep physics. They think that, so they've got prototypes. They think that with a quantum computer you'll be able to do we're talking several orders of magnitude more processing power. So for example, they believe that every algorithm that we use today to encrypt stuff could be unencrypted using quantum computing really quickly. So today, when you encrypt your password, you rely on the fact that there is no computer around that can quickly decrypt it. So quantum computing thinks that they'll crack that problem. So the question, therefore becomes, what could you do with these sorts of algorithms with, vast more processing power? It's a very interesting question. I don't know the answer. I've listened to quite a lot of podcasts on quantum computing. I think it's quite scary, actually.
Me too. Me too. I was just interested in your take, but yeah. I'm the same.
Yeah. Okay. Good question.
Thanks.
So it sounds like it's very open at the moment in terms of opportunities with HMRC and anybody else, basically, because there's lots of ways, presumably, of stitching the algorithms together, and no one's kind of found the killer way of doing it for many things by the sounds of it. So there's lots of opportunities out there.
I think so, yeah. But it's about understanding what you can do with it, and then finding people who've got that problem and gluing those two together. I think that's the crux of the matter. I mean, you're probably aware of this P11D stuff that we're currently doing, yeah? So, there you're effectively trying to make sense of what people have either written or typed, and you're trying to. So one area that we've also looked at are things like, if you haven't returned your tax form, you're going to get fined, but you can fill in a form that says, tick, I was sick, tick, I was out of the country, or other, and you can write a big long, I've been in hospital for 15 weeks with appendicitis, whatever. And today, again, we're using natural language processing to read the box called other and categorize it. I read all that stuff, and actually that means they were sick. I read all that stuff, and that means they were out of the country. And, without that, HMRC have to have an army of people who read it and understand it and categorize it. And they're just some examples of where it's beginning to get into the HMRC view. Obviously, fraud detection and all that's well in their world, isn't it? Good. Thank you very much. Hope that was helpful.
Yes, I think absolutely fantastic, Les. So, part of the reason for doing this, and hopefully if you liked it, we'll do some more, is just to get people thinking about how it might apply when you go out and talk to your customer and kind of as they explain their problems to you, whether something like this could help them, basically. So that's part of the reason for doing it. We'll talk with Les, because I think, I got a lot from it, so hopefully other people did, about other topics we might look at in the future. But could we give Les a show of appreciation, please? Thank you. Very much, Les. Really appreciate it, and we'll talk more about other topics.
Okay.
And if people have topics they'd really like, let me know, and then Les and I can kind of look at.
Yeah.
What we're really looking for is topics that apply across the piece, so they're kind of cross-cutting ones is what we're really after.
Yeah.
But
I suppose there's a couple of examples. We've spoken to other groups about DevOps and Agile and all that stuff, which you might be interested in.
Blockchain.
Blockchain? I can talk about blockchain, yeah.
Okay. Yeah. All right, brilliant. Thank you, Les.
Good. Okay.
Thank you all for attending. Thanks,
Cheers then.